let's talk about these examples. If you're able to complete this, and the last page is all about half-life, and I hope that will train you, we'll do one question minimum from each of these sections in hopes that you'll be able to, prepare yourself for our quest. Right? So if you have this in front of you, all you need is a calculator and a pencil. Part 1, determine key information useful for creating an equation, and then write me the equation. Okay. Use the equation to solve for the final value. All right, here we go. I'm going to read it slowly. It's up to you to pull out the information you need. By information you need, take a look at this equation, or these formulas here. When we're talking about growth, when we're talking about decay, the formula will change. So, part 1. Is question 1 talking about a growth or a decay? Read it carefully. Am I growing or am I shrinking? Or am I getting smaller? Yeah, it's going to grow, which means this is my formula. Now let's pull out information. An investment of $2,000 was placed in a portfolio somewhere, which means that's my starting amount. The portfolio offered 5% interest every year. That's my growing rate. And it says, find the balance after 6 years. That must be my time. Just pulling out information. Let's plug it in. I'll do this for you. VF. So it's find the balance. In other words, they're looking for a VF. I'm going to put that as a question mark. VF is equal to 2,000. 1 plus the rate. 6 years. At this point, every example, I'll ask someone to calculate for me just to make sure you're doing the calculations correctly. Yes? 0 point. Oh, no, it's because I'm wrong. My bad. That is a 5. Definitely it's a 5. I think I looked at the 6 and just assumed that it was. Someone with a calculator. Yep. So with that, yep. 80 and 191. So it's money after all. So I'm going to count to 2 decimal places. So therefore, the investment is worth 2,680 and 19 cents. So it's not bad. It's not bad if they're talking about realistic. It's not the best. It's not bad, especially in this economy right now where it seems like we're approaching a recession. Okay. While you're working on that, we're going to jump to number 3. And I'd like you to once again, if you're with me, then I'd like you to read that and tell me if it's a growth or a decay. It's really important to use the proper formula. Yep. Absolutely. Why do you say that? Keywords. There's no mathematical hint. It's just an English keyword. So that is a decay. So that means my formula is going to be that. Do you have a question? Worth. Silly. My bad. See if I can write that better. Worth. All right. So the my population of 25,000 was hit with an illness. So that must be my starting value. It decreased by 1%. That must be my every day. What will the mice population be after 30 days? So I'm asking what VF is. But time is 30 days. So here's a thinking bit for you. Am I okay with leaving it for 30 days, or do I have to change it into years in this case? Yeah, the rate is given in days, so we're okay with days. Let's do it. Put it you will get a study sheet. VF is equal to VI 1, careful, minus 0.01 for 30 days. Yep, you got it? Oh yeah, come here. Oh, for you, it would be YX. So it's like 2 power of 5. That's a big number. There you go. For you, you might have to use brackets if you're using that for, yeah. Welcome. Yep. And now is a good time as a class. Let's learn to, remove any doubt when you're using your calculator. What's your answer? Let's see, 18,000. Yep, 0.51, but we can't have 0.5 of a mouse. That's gross, right? We don't want to talk about half of a mouse here. So we'll say approximately, because it's decreased, if you lost half of a mouse, you lost the whole mouse, okay? So therefore, the mouse population will be 18,492. The mouse population. $492. This 492.5. So it's a question of, is it 18,493 or is it 18,492? I'm assuming since we lost half of the mouse, that mouse is, gone to mouse heaven or whatever we know about animals. Okay. So here is, I'm gonna say it straight, on our quest next week, Tuesday, very straightforward growth, very straightforward decay. If this question is not straightforward and you really have to think about it, I highly recommend you practice a bit more. Go back to our previous lessons and do what you need to do. This is going to be entry-level questions. Let's move on. Any questions before we go to the next page? Moving on. Take a look at part 2. It's a slightly different variation, but the same equation, right? I'm not going to say anything. I'm not even going to read this. Instead, I'd like you to sort of discover, because this might happen on a test as well. Read the question. Are we talking about a growth here or a decay? Brendan, Cameron, follow along with me. You can take breaks after, but we just got to a new question, so let's finish this first. Yep.
Would that be decay, right?
Is it?
Or the top one?
Yeah, the number 5.
Number 5 would be
Right. So it's growth. So I know it's going to be VF equals VI1 plus R. Okay. The number of mosquitoes at the beach has grown by 10% every year since 1999. 10% doesn't seem like much, but number 1, we hate mosquitoes, and number 2, that's gross. Right? If there were 4 million mosquitoes in 2021, how many were there in 1999? So first off, let's calculate the time. No. The question gives you R. R is 0.10. Time is 2021 minus 1999. That is 22 years. Okay, pop quiz. 4 million. Is that the amount we have right now, or in the future, or the amount that we have in the past? Sorry, not my past, but based on 2021 versus 1999. Is it the amount that we have at the end of that period or in the start of that period? Oh, careful. If there were 4 million in.
Yeah, that's
Oh, okay, yeah. So as in the start of that number. Yeah. You're right. So if that's the case, that means my final value is 4 million. Which means, what is the value I don't have? This time it's VI. Take a look at how different this one is set up compared to the previous. Do you see the difference? So here is how we go about questions where we have the final value, we don't have the initial. Would someone please do 1 plus 0.1 and then all of that to the power of 22? Tell me what that is. Take your time, just much, because I know it's distracting. Yep. 8.140 blah blah blah, right? Okay, so let's leave it at that, and that is still 4 million. So what is VI? How do I get VI all alone? In this particular question, you would have to get VI all alone by doing some algebra. You need to divide both sides by 8.140. So the initial population was approximately 4 million divided by 8.14, approximately 400.49. So let's just say it's 400. Okay. Therefore, there were 491,400 mosquitoes, mosquitoes, in 1999. Seems like a lot, but you gotta imagine the geography that they'll take up. And I'm not too sure about the statistics, but the general trend is true. Mosquitoes are increasing. The temperature in Canada is getting warmer. I remember when I was in high school, my friend got all the symptoms of West Nile, which is supposed to be like a tropical kind of, problem. But He got it in Toronto. So there are mosquitoes that are starting to migrate north from warmer temperatures. Things like Lyme disease and ticks and all that kind of stuff, it wasn't an issue in Toronto until recently. When I was a kid, I knew how I could run barefoot on the grass, no problem. But now times have changed. Okay? So here it is. That's a growth. Number 6 is actually a decay problem because the word depreciate. And it's also a question where I ask for the initial value. So I think you can do the rest of these on your own. Okay. So we'll clear that. Part 3. Take a look at how this question is a little bit different. This question asks you to calculate R. This one's particularly hard. Okay, so put a little star next to it. Okay. This question is asking you to find R, and I'll show you how that's hard. This is very different, so pay attention. The world population in 2000 was approximately 6.08 billion. In the year 2024, it's estimated to be 8 billion. So right now, it's basically like 7.9 billion. Thank you. We're going to determine an equation and then identify what the growth rate is based on that, and figure out what the population in 2045 might be. Here we go. The initial value is going to be 6.08 billion. The final amount is going to be 8 billion. Notice how I'm not adding the zeros on there because I'm assuming that I'm going to put it in my head. This is in billions. I don't know what my growth rate is. It says that it asks for the growth rate. So between the first value and the last value, how much time has passed? Well, 2024 minus 2000, this is 24 years. So up until now, I don't think it's any different. VF, it's growth after all. VF is equal to VI 1 plus R to the power of 24. Allow me to give you 30 seconds. Once you've copied this, look at the equation and notice that it is very difficult to find R. If you are able to solve R easily, either you know what I'm going to do next, or you're doing algebra incorrectly. Tell me your main problem. I'm going to start the first step by dividing both sides by 6.08 because my goal is to get R all around. So I'm going to first get rid of whatever's on the outside of the bracket. What is that equal to? What do you get? 1 point. Eight divided by 6.08. I'm going to write as much as I can. All right, so this is today's challenge. This is the main challenge for today. If I were to give you a question like this, where I ask you to find R, how do you get rid of an exponent? In fact, what's the opposite of an exponent? What's the inverse, rather, of an exponent? Yeah. It is a square. Well, if it was a square, so here's a quick reminder. Opposite of an addition is a subtraction. Opposite of a multiplication is a division. So what's the opposite of a square? It is a square root. And here's the kicker. What is the opposite of something to the power of 4? It is the 4th root. You see the pattern? What's the opposite of something to the power of 100? It is the 100th root. So how this changes, and please use a highlighter, put a sad face, do whatever you need to mark this question. To get rid of an exponent of 24, you are going to root 24 on both sides. Shameless plug, here's the proof. If I have 4 equals x squared, how do I get rid of the square? Square root both sides. The square root and the square are equal to each other, or inverses of each other. So x equals 2. Okay? So in your calculator, tell me what that is. If you're not sure how to do this, you might have to look for this button that looks like that on your calculator. Final answer is 1.0115. 00 something something. See if you can get it. This part's really important. So I'll wait for you. Yes, Kevin. So typically, I'm not sure what your calculator looks like, but you would do this. To put that in, you would type in a 24, and then you would press the button that has this on it. And then you put in 1.315789. And you press the equal sign. Make sure you know how to do that on your calculator. Everyone try it. All right. And what's R? Did everyone get this? Yeah. Pardon? Okay, 0.115. Can you tell me that as a percent? Because that decimal might mean nothing to some people. What is that as a percent? 1.15%. You're basically, right? Because percent means divided by 100. The opposite is you multiply by 100 and you get out your percent. So that's the growth rate. So if that's the growth rate, what's my overall equation? So part B, so this is all part A. Part B, what is my equation? It would be final value equals 6.08 billion, 1 plus 0.0115 to the power of t. Let me try to move this so that you can see it. Why am I doing this? Well, now that we have an equation, the question does ask you, what is the population in year 2045? In other words, what is the final population if the time is 45 years? Question, Charlie? And you can just solve that. The answer key will be available online, so don't worry. I'm actually working on it right now to make it nice and clean. Now, I'll wait for people. I'll give you another minute or so. Let's do this. All right, so that was a minute or so. I'm going to clear this. My final example for today, you have to take a look at half-life. I'm going to read this question, part 4. Every question has enough information to determine an equation that models the scenario. Please put a little star next to this. This is the half-life formula. It's exactly the same, except two changes. You know how before it's VF is equal to VI, and since this is a decay, like half-life, it's 1 minus R to the power of T. Everyone's okay with that so far? Does that ring a bell? Half-life, the key word half. What do you think my base is going to be? What am I going to be multiplying by every single time if I'm saying it's half-life? Yep, 0.5. So I am reducing, I am decaying by 50%. So 1 minus 0.5, it's always going to be 0.5 as the base. When you see half-life, it's automatic. But there's one more addition. Time, knowing that this is always going to be fixed at 0.5, the time has to be altered. The exponent always has a number under it. And I have a little symbol. It looks like a reverse H hat. That's a physics symbol called lambda. It looks like this. If I do something like that. Okay, it's like a reverse H or an upside down Y. It's called lambda, and that is what we're going to represent half-life with. The amount of time it requires to get to half. Here we go. What is the decay rate? A. What is the decay rate? It's a given. What was my R? What did I subtract by? Oh man. 1 minus something gave me 0.5. 1 minus something is 0.5. 1 minus something is half. Yeah. My decay rate automatically is 0.5. So that was essentially a kind of a given question. It's a trick question. In this question, what is the length of my half-life? How long does it take for it to break down to half? Read the question. A hospital prepares a 100 milligram supply of technetium-99, which has a half-life of 6 hours. So what's my lambda? What's my half-life? That's it. It just as is. It's 6 hours, yeah. So it takes 6 hours to break down half. That is the meaning of half-life. Okay, write an equation to represent this problem. Okay, I have an initial value of 100 milligrams because that's what they said. I have my R, I have my lambda. That's all I need. The formula or the equation for this question is 100, 0.5 time divided by 6. And I think the hardest part that you have to watch out for is the lambda portion, because you know this is always going to be 0.5. So part D, how much technetium will remain in a patient after 75 hours if time is equal to 75? VF is equal to 100 times 0.5 to the power of 75 over 6. And the rest is just plugging into the calculator. So I will do that. Please practice this. If you have a calculator, just go that extra mile and try it, because the exponent is a fraction. I want to make sure no one's making any bedmass mistakes on their calculator. Someone who hasn't tried it today, either Nicole or Brendan or Ignayan or even Sage. Okay. Make sure you give it a shot. I know it sounds weird, but the amount of time I saved on tests and exams because I was really fast with my calculator, and also the amount of times I got myself out of a jam because if I did something wrong, I could do it all over again in like seconds. Got me out of a lot of tough situations. Final answer, yeah? No? Go ahead. 0.0. No? Yep.
0.017.
Yeah, 1726, blah, blah, blah. So this is milligrams already, so it's already a very, very small amount. So how about I just do 17, that's 3, that's milligrams. So that's basically micrograms, 17 micrograms. That's. Pardon? I'm not adding. So what you want to do, let's do it first in order. You want to accomplish this first. So I would say plug in 0.5 to the power of, open a bracket, 75 over 6. And solve that first. If you're using your phone calculator, the phone calculators are not made to do math well. Okay, they're made to do arithmetic, like single operations. So it's a little annoying to punch in the numbers properly. If you are happening to use a phone, you know you can't use it on a test, but if you're using it right now, I recommend you, spend $1 and get a good scientific calculator. I have a free one. Every time I open it, like every 24 hours or whatever, every time I use it, after giving me like 3 calculations, it shows me an ad. And then I don't see an ad for the rest of the day. But I mean, it's worth it for me. Okay. The same thing works here. And please note, I'm trying to make this real to you. These materials that are used in the medical field, it's actually true. Here's an interesting one, like iodine 131 is used for water pipes. Yeah, that's true, but radioactive iodine is also used for your thyroid. I don't know how many people here know others that have thyroid issues. I actually had a friend who ended up having thyroid cancer and had to remove it. And she's young, right? I had thyroid cancer, she had to remove it. And so she's taking medicine every day to compensate for thyroid hormones. You need thyroid hormones to grow, to reset, to heal yourself, blah, blah, blah. What they do is they get you to ingest radioactive iodine. That might sound scary, but it's not necessarily true. It's harmless per se. Iodine, when you ingest it, all collects in your thyroid because it needs iodine to do things, right? So that the thyroid will collect all the iodine, and because the iodine will give off radioactive energy, the doctors will take a picture of your neck, right, using a particular equipment, and they will be able to see the exact shape and condition of your thyroid without cutting you open. Because it's giving you light. It's giving you light on a machine, right? It shows the intent. So it's pretty amazing. Right? And in about 7 to 14 days, or a week or two, the iodine radioactivity just completely disappears. It decays naturally. The rest of it will come out of your body through waste. It's really, really cool. So I really hope that you will take some of this this half-life and these exponential questions seriously. There's so many applications of this in this life. And the more you get into math, the more applications you will see. But that's a shameless plug from my math teacher. For the rest of class, I really hope that you will take these examples to heart, that you will use them as reference when you try all the other questions. When we come back on Monday, being the final day of practice for this test, I will take up any and all of the questions you have not done or you had trouble with. Any questions of what the expectations are? Any questions about the material? Okay. So there are still about 20 minutes. I hope that you'll use it wisely. Study hard.